consider the fortress. It is the ultimate expression of permanent, immovable power. Walls of reinforced concrete, feet thick. Cannons emplast in steel-reinforced bunkers. Deep underground command posts, safe from any artillery barrage. It is a statement carved in stone. I am here. This land is mine. To take it, you must break yourself against me. Now, consider the airfield. It is the opposite. It is fluid, temporary, a pivot point for projected force. It is not a wall but a springboard. It does not defend, it attacks. Its power lies not in its permanence but in its very impermanence. It can appear and then, it can vanish. In the Second World War, the master strategists of Nazi Germany, men like Rommel, von Rundstedt, and Kesselring were masters of the fortress. They looked at the coast of France and saw a defensive line, an impenetrable wall they called the Atlantic Wall. They built colossal concrete forts, U-boat pens that are still standing today, and massive gun emplacements designed to dominate the channel. They were preparing for a battle of concrete and steel, a head-on collision of titanic forces. They were preparing for the wrong war. Because while they were pouring millions of tons of concrete, dreaming of a static battle of attrition, their enemy an ocean away was perfecting a weapon they could never have conceived. A weapon not of concrete but of perforated steel. A weapon that wasn't a single massive fortification, but a web of over 3,000 miles of temporary mobile airfields that could be laid down in hours and moved forward with the front line. The German generals built fortresses, never knowing that America was building a secret, disposable highway in the sky. This is the story of how a simple, unglamorous piece of metal, the pierced steel plank, shortened the war and changed the face of combat forever. Our story begins not in a factory but in a field. A wet, miserable, churned-up field in England. It's 1942. The United States Army Air Forces are arriving in force, a flood of men and machines destined to take the war to the heart of Nazi Germany. But they are facing an enemy more persistent and more frustrating than the Luftwaffe, the weather. England is wet. Its grass airfields, perfectly adequate for the lighter aircraft of the RAF, are turning into quagmires under the weight of American heavy bombers, the B-17 Flying Fortresses and B-24 Liberators. These are behemoths, weighing tens of thousands of pounds. Their tires sink into the soft ground. A few days of rain and an entire airfield is operational. Planes are bogged down, unable to take off or land. Missions are cancelled not by enemy action but by mud. The problem is one of logistics and time. To build a proper all-weather airfield from scratch requires vast quantities of aggregate, stone, gravel, sand. It requires heavy machinery and most of all it requires time. Months of it. And this is just in friendly territory in England. The grand strategy, the plan to defeat Nazi Germany, involves moving this air war across the Channel, into France, Belgium, Holland, and eventually Germany itself. How do you do that? How do you advance your air power, your most crucial component for tactical support and strategic bombing, when every forward advance requires you to wait months for a usable airfield to be built? The German High Command understood this problem. In fact, they were counting on it. Their intelligence told them that the Allies would need to capture major ports to supply their advance. And they knew that building new airfields would be a slow, painstaking process. They believed the battle for Europe would be a series of set-piece engagements, with defined front lines. They could fortify those lines. They could prepare. What they couldn't prepare for was an airfield that could be built in a day. The solution was born not from a grand, top-secret weapons program, but from sheer, desperate necessity. The U.S. Army Corps of Engineers was tasked with finding an answer. And they found it in the unlikeliest of places, a manufacturing technique used for industrial flooring. The answer was a single sheet of steel, 10 feet long, 15 inches wide. It was pierced with 87 holes in a precise pattern, and its edges were designed to interlock. It was called the pierced steel plank or PSP. But to the millions of soldiers who would handle it, it was known simply as Marston Mat, named after the first airfield it was tested on in the United States. It looked simple. Deceptively simple. Just a perforated metal sheet. But this sheet of metal was about to become one of the most revolutionary weapons of the Second World War. So, what was so special about this piece of perforated steel? Its genius was in its multifaceted design, a masterpiece of military engineering. First, the holes. They weren't there to save weight primarily. They were there for drainage. Rain would fall through the matting, preventing water from pooling on the surface and turning it into a skating rink. The holes also provided instant traction for aircraft tires, a critical feature for landing on wet surfaces. Second, the interlocking edges. Each plank had a curved, upturned edge on one long side, and a flat, slotted edge on the other. One soldier would hold the new plank at an angle, hook the curved lip into the slot of the already laid plank, and then slam it down flat. Clang. It locked into place. It was so simple that with a small crew, you could lay down an entire runway at a speed of 1 foot per second. Think about that. A foot per second. A 5,000-foot runway, long enough for a heavy bomber, could, in theory, be laid by a dedicated battalion in a single day. A single day. But the miracles of the PSP didn't stop there. Because it was steel, it was incredibly durable. It could withstand the immense weight and the searing heat of bomber exhaust. AB-17's engines could blast directly onto the PSP without warping it. Tanks and trucks could drive over it without breaking it. And perhaps its most brilliant feature, it was reusable. When an advance moved the front line forward, the engineers could simply pick up the planks, truck them to the next location, and lay them down again. It was a portable, reusable airfield. An entire logistical ecosystem in a stack of steel. The production numbers are staggering. American mills, operating at a pace never before seen in history, produced over 2 million tons of PSP. Laid end-to-end, the total output would stretch for over 300,000 miles. Enough to circle the Earth at the equator 12 times. But in the context of the war, it created over 3,000 miles of actual runways, taxiways, and hardstands. This was the secret weapon. Not a new bomb or a faster plane, but a system. A system for creating air power anywhere, almost instantly. And as the planning for the greatest amphibious invasion in history began, this system would become the linchpin of the entire Allied strategy in Europe. Now let's cross the channel. Let's step into the mind of the German commander, Field Marshal Erwin Rommel, tasked with defending Fortress Europe. Rommel, the Desert Fox, was a master of mobile warfare. But even he saw the defense of Normandy as a static problem. He toured the Atlantic Wall in 1943 and 1944. He saw the massive concrete casemates housing colossal naval guns. He saw the beaches littered with obstacles, the fields behind them sown with anti-glider poles known as Rommel's asparagus. He demanded more concrete, more mines, more obstacles. His philosophy was simple: stop the invasion on the beaches. The first 24 hours would be decisive. He, and every other German general, envisioned the battle thusly: the Allies would secure a beachhead. They would need to bring in their supplies through captured ports. They would be bottled up for weeks, maybe months, as they slowly built up their forces and constructed rear-area airfields. This would give the Wehrmacht time to bring up their panzer reserves and launch a devastating counterattack, driving the invaders back into the sea. The entire German defensive plan was predicated on this timeline. A timeline dictated by the slow, plodding pace of traditional construction. They had no idea that the Allies had no intention of playing by those rules. The Allied plan, Operation Overlord, had a secret, hidden component. It was called the Advanced Landing Ground, or ALG. The strategy was breathtakingly audacious. Within hours of the landings, even as the beachhead was still a deadly, chaotic fight, engineers would follow the infantry. Their mission: to identify flat, open fields behind the front lines. And they would not build airfields. They would unroll them. While German spies and reconnaissance pilots were looking for the telltale signs of airfield construction, quarries, gravel pits, fleets of trucks hauling aggregate, the Allies were preparing to create airfields out of nothing. The PSP was invisible to German intelligence because it wasn't a construction site, it was a warehouse item. It was stacked in neat bundles on ships and trucks, indistinguishable from any other piece of military hardware. This was the fundamental clash of philosophies. The German mindset, for all its tactical brilliance, was rooted in a European tradition of fortification and permanent defense. The American mindset, born from a continent-sized nation and an industrial genius, was about mobility, scale, and temporary solutions. One side was building a wall. The other was creating a network. The moment of truth arrived on June 6, 1944. D-Day. The chaos of Omaha, Utah, gold, Juno, and sword beaches is the stuff of legend. But behind the beaches, a different kind of miracle was taking place. Even as the fighting raged just miles away, U.S. Army Engineer Aviation battalions and their British counterparts went to work. One of the first locations was a field near Saint-Pierre-du-Mont, behind Omaha Beach. The field was chosen not for its ideal location, but for its proximity to the front. It was just a farmer's field, dotted with the anti-glider poles Rommel had ordered. The engineers moved in. Their first task was to manually clear those poles, often under sporadic sniper and artillery fire. Then the trucks arrived. They carried the bundles of PSP. And the symphony of construction began. Teams of men, working with practiced efficiency, began the process. clang, clang, clang. The sound of steel locking into steel echoed across the Norman countryside, a strange industrial counterpoint to the roar of artillery. They started with a runway, just a single strip. Then taxiways. Then hard stands, circular parking spots for aircraft. Within 48 hours of the first landing, while the battle for the hedgerows was still at its most brutal, the first Allied fighter planes, P-47 Thunderbolts and British Spitfires, were touching down on this brand new steel mat airfield. It was designated ALGA-1. The impact was immediate and catastrophic for the Germans. Imagine being a German infantryman. You've been told the Allies are pinned on the beach. Their air power is limited to aircraft flying from England, which have only a few minutes of fuel over the battlefield. Suddenly, you look up and see enemy fighter bombers overhead, constantly. They are strafing your positions, bombing your supply columns, spotting for artillery. They are there from dawn until dusk. Where are they coming from? The German commanders were baffled. Their intelligence reports spoke of airfields being operational behind the American lines. But that was impossible. It had only been 3 days. They assumed the Allies must have captured a pre-existing German airfield. But reconnaissance photos showed something bizarre. The new runways shone. They had a distinct, metallic sheen. They were not the dull gray of concrete or the green of grass. They were silver. This was the first big surprise, the first moment the German high command realized the rules had changed. The Allies weren't just fighting their way through the Atlantic Wall. They had brought their own infrastructure with them, like a hermit crab carrying its shell. And this was just the beginning. As the American and British armies broke out of Normandy in late July and August of 1944, the pace of the ALG construction became frenetic. The Allies were advancing so fast that they were outrunning their own supply lines. But they never outran their air cover. Engineers would leapfrog ahead of the main forces. They would secure a field, and within hours the clang, clang, clang would begin. A new airfield would appear on the map. Fighters and tactical bombers would move in, their range extending by dozens of miles every single day. This leapfrogging of airfields meant that the retreating German forces never got a respite. They were constantly under the eye and the guns of the Allied air forces. The 3,000-mile web was being woven, strand by strand, across the face of Europe. But the story of the pierced steel plank isn't just a European story. If the environment in Europe was challenging, the Pacific theater was an engineer's nightmare. And it was here that the PSP truly proved it was a war-winning weapon. The Pacific War was a war of islands. Tiny, isolated specks of land, thousands of miles from friendly bases. The Japanese defenders knew that without an airfield, an island was often useless to the Allies. They fortified accordingly, concentrating their defenses on the few viable spots for runway construction. The Allies, armed with the PSP, turned this logic on its head. Take the island of Tacloban in the Philippines. When General MacArthur's forces landed, the existing Japanese runway was a bog, completely unusable. The soil was soft and waterlogged. A conventional airfield would have taken weeks. But U.S. Navy Seabees and Army engineers laid down PSP directly over the mud. Within days, P-38 Lightnings were operating from it, providing crucial air cover for the invasion fleet. Or consider the frozen hell of the Aleutian Islands. Building on permafrost was a nightmare. Any disturbance of the top layer would turn the ground into a soupy mess. PSP provided a stable, insulating layer that prevented this thawing, creating stable runways where none should have existed. But the ultimate test was the island-hopping campaign across the Central Pacific. The U.S. strategy was to bypass heavily fortified islands and seize smaller, less defended ones. The question was, how do you turn a small, coral atoll with no infrastructure into a major airbase for B-29 superfortresses, the heaviest bombers of the war? The answer once again was the humble mat. On islands like Tinian and Saipan, engineers created what were, in effect, artificial landscapes out of PSP. They built runways so long and so strong they could handle the immense weight of the B-29s. These were the basis from which the firebombing of Japan and the atomic bomb missions were launched. The Japanese, like the Germans, were prepared for a different kind of war. They built strong, fixed defenses on key islands, expecting the Americans to bleed themselves white in frontal assaults. They never anticipated that the Americans could land on a seemingly worthless island and, within a matter of weeks, transform it into the equivalent of a major industrial airbase. The PSP gave the United States a geographic flexibility that its enemies could not comprehend, let alone counter. The war ended in 1945. The colossal fleets of bombers and fighters were scrapped or put into storage. The concrete forts of the Atlantic Wall remain, slowly crumbling into the sea, tourist attractions and monuments to a failed strategy. But what happened to the 3,000 miles of steel airfields? This is the final and perhaps most surprising chapter of our story. The PSP didn't just vanish. It had a second life, a peaceful legacy that literally helped build the modern world. After the war, there was a massive surplus of pierced steel plank. The US government sold it off for pennies on the dollar. And American ingenuity found 1,000 new uses for it. It was used to build emergency roads and bridges in flood-ravaged areas. Farmers used it for cattle walks, barn floors, and temporary bridges. Construction companies used it for temporary access roads on soft ground, a practice that continues to this day. In remote parts of Alaska and Canada, PSP was used to create landing strips for bush pilots, opening up the wilderness for development and travel. But its most profound legacy is in the very infrastructure of the developing world. Vast quantities of PSP were shipped as part of the Marshall Plan to help rebuild Europe. It was used to patch war-damaged runways, create temporary roads, and serve as foundational material for new construction. In a very real sense, the same material that helped defeat the Axis powers helped resurrect their nations from the rubble. The pierced steel plank is a perfect metaphor for the American industrial effort in World War II. Not always glamorous, often overlooked, but fundamentally world-changingly effective. It was a tool of pure pragmatism. It solved a simple, critical problem with an elegant, mass-produced solution. The German generals in their concrete forts were fighting the last war. They were masters of a dying art, the art of static, positional warfare. The Americans, with their 3,000 miles of steel mat, were fighting the next war, a war of mobility, of air power, of industrial logistics on a global scale. They were not just building runways. They were building the very concept of rapid, global power projection. The modern U.S. Air Force's ability to deploy to a bare base anywhere in the world within days is a direct descendant of the engineer aviation battalions laying PSP in a Norman field. The aircraft carriers that project power from the sea are the spiritual successors to the portable airfield. The story of the pierced steel plank is a story about how the most decisive weapons in war are not always the ones that make the loudest explosion. Sometimes, the most decisive weapon is a quiet, simple, brilliant idea. An idea you can hold in your hands. An idea that can be laid down 1 foot per second, to create a highway in the sky and change the fate of the world. So the next time you see a construction site with temporary metal road plates or drive down a highway, remember the clang, clang, clang of steel in a French field. Remember that sometimes the greatest walls are not made of concrete, but are overcome with perforated steel and sheer, unyielding ingenuity. The fortresses still stand, monuments to a defiant past. But the phantom runways, the 3,000 miles of steel that won the war, have vanished, leaving behind only the world they helped to create.